Laser therapy is a well-studied method to eliminate chronic and acute pain. The goal of this non-invasive application is to deliver light energy to tissue needing treatment, which reduces pain, inflammation, and increases circulation. This unique technology utilizes superluminescent laser diodes to deliver photons to diseased or traumatized tissue. Photons are particles of energy that are selectively absorbed by the cell membrane and intracellular molecules, resulting in the initiation of a cascade of complex physiological reactions, leading to the restoration of normal cell structure and function. The primary pathway is the absorption of energy, which increases production of ATP and changes in the cell membrane, photochemical and photophysical effect. The secondary pathway is based on what the cell does with the energy. It releases growth factor, initiates protein synthesis, increases nitric oxide production, and proliferates cell membrane. Its tertiary pathway is the systemic effects caused from the indirect exposure to laser, called photohemotherapy.
The challenge to practitioners has been how to maximize the benefits of laser therapy to effectively deliver photons to tissue depth without a harm or risk of hazardous heat, which is normally associated with high power.
Super-pulsed laser technology by Multi-Radiance provides an optimal and safe mechanism of energy delivery, combining three clinically proven wavelengths for optimal tissue penetration: 660 nanometers, 875 nanometers, and 905 nanometers, which covers nearly the entire therapeutic window for light and create a cascade effect. The 660 nanometers red light photons penetrate a relatively shallow tissue depth, but they are heavily absorbed cytochrome C oxidase and have higher amounts of energy than infrared photons. Red light exerts a very favorable therapeutic effect on inflammation. The infrared 875 nanometers non-coherent light penetrates deeper tissue than the 660 nanometers and offers a unique biological response. The increased cell membrane permeability and removal of pain signals at the source are just some of the effects. The super-pulsed laser at 905 nanometers provides high-powered light in 100 billionths of a second pulses that drive to photons up to 10 to 13 centimeters deep into the tissue without a harmful thermal effect. The full 25 watts of power is being generated at the peak of the pulse, creating high energy density. In addition, the energy delivered at 905 nanometers wavelength is most efficiently absorbed by hemoglobin in the blood.
More hemoglobin reduction and increased circulation of blood means more oxygen is supplied to the cells. This creates a beneficial systemic effect throughout the body. When these multiple wavelengths are combined, there is a 100% increase in availability of light below the skin, and confirms the presence of triple cascade effect, which was validated by the Pillars paper research.
The static magnetic field assists in keeping photoactivated molecules in a disassociated scattered state, thereby enhancing their potential activity and energy levels at both molecular and cellular levels, resulting in more energy being absorbed by the tissue. Another important factor of multi-radiance technology controlling the depth of penetration is accomplished by varying the frequency at which light energy is being delivered. The higher frequencies penetrate relatively shallow tissue and have an inhibiting effect on pain, where lower frequencies enable deeper tissue penetration and create a stimulatory effect on the tissue. The constant use of the same frequency as found in continuous wave lasers causes the body's tissue homeostasis and adaptation to the laser's effects, thus limiting its therapeutic power. The Multi-Radiance proprietary technology laser sweep varies its frequency to prevent the tissue from adapting by utilizing a range of frequencies that sweep from highest to lowest during treatments. By varying the frequencies, each laser impulse effectively changes the laser's target depth of penetration. Such changes not only impact the depth of the energy, but also the rate at which the energy is delivered. The combination of the variable depth and dose rate reduces risk of biological adaptation to treatments. The electrical properties of the skin and the underlying tissue change in response to injury, pain, and trauma, as well as stimulation. Laser Stim Target is sensitive to these changes and immediately adapts to provide an appropriate level of stimulation. As the body responds to the stimulation, the impulse adjusts dynamically to the feedback from the electrodes in contact with the skin, engaging in a process of contact interaction that provides optimal treatment and also avoids the body's natural tendency to accommodate to the stimulation. The efficacy of multi-radiance lasers has been validated in vitro, in vivo, in laboratory-controlled studies, and in clinical practice. The multi-radiance lasers deliver less heat than continuous or mechanically pulsed lasers to maximize the phototherapeutic response.
The studies have shown that synchronization of multiple wavelengths of light is more effective than any one wavelength alone.
The multi-radiance technology delivers more beneficial light to the target tissue compared to Class 4 lasers.
Globally, multi-radiance technology is utilized to treat a broad range of conditions and has approvals and clearances in the US, Canada, Australia, and Europe.
Today, multi-radiance lasers are used by over 80 professional and collegial teams of sports, U.S. and Canadian national teams, military and Veterans Administration facilities, and tens of thousands of clinicians in over 30 countries worldwide.
Visit us at multiradiance.com, multiradiance.eu, or call 440-542-0761.